I hope my voice would be audible, and let's see this works or not. Stream quality is excellent. Yeah, it works. So I went to have food, I listened to music, and now I'm back. I just don't want to use social media, X or LinkedIn or Telegram or anything. I just want to read Jenkins. Learning continuous integration. In this chapter, a comprehensive introduction to continuous integration is presented in Golden Circle theory. Practical implementation of CI, ये तो पढ़ लिया था. In this section, we will try to answer what CI is in two basic steps. We will first attempt to define CI, then examine its principles. Am I audible? Principles. What CI is in two basic steps. We will first attempt to define CI, then examine its principles. Am I audible? Principles. What C? Now it is just echoing. So I think I should turn off my audio because we will never be using this audio. Now it won't repeat. It didn't. Okay, cool. Now I'm minimizing it and going to Jenkins book. In this section, we will try to answer what CI is in two basic steps. We will first attempt to define CI, then examine its key principles. Defining continuous integration. CI is software development practice in which developers regularly integrate their code changes into projects' shared work area and inspect their changes for build issues and other quality related problems. Integration is act of submitting your modified code to the project's main branch potential software solution. It is technically done by merging your feature branch to your main branch in trunk based development, a Git based branching strategy. I have to read that Git based branching strategy completely again. And additionally, by merging the feature branch into development branch in Git flow workflow based development, another Git based branching strategy as shown in the following figure. Rebase merge main branch, developers branch, developer B's branch, developer A's branch. Rebase is when you take things from merge branch, and merge is when a main branch, and merge is when you merge your own code into the main branch. Got it. CI is necessary to detect and resolve issues encountered during and after integration as early in the cycle as possible. We can understand from the figure. This can be understood from figure when a developer commits and push. When a developer commits and merges their code changes to the remote branch, they may experience merging difficulties, if not build failures, build unit tests, or failed integration test. A merging problem can emerge if developers do not routinely rebase the code from the remote trunk branch on their local branch. यहाँ पे मेरे को थोड़ा थोड़ा समझ आ रहा है, बट क्योंकि गिट अभी मैंने पूरा ढंग से नहीं किया है, गिट वाली बुक पूरी ढंग से नहीं पढ़ी है, तो थोड़ी थोड़ी चीज़ें ऊपर से जा रही है. Similarly, the code may fail to compile. Similarly, कहाँ पे थे हम? Similarly, the code may fail to compile owing to compilation issues, failing test indicates a defect, which is a positive thing. If any of these issues occur, developer must adjust the code to correct it. Now that we have defined CI, let's look at keys, ideas that underpin it. Some of it, I suppose, you have already guessed. Let's dive. Pulling frequently. In context of CI, a pull simply updates your local branch with the most recent code changes from the remote branch, while push publishes your code changes to the remote branch. Git, the popular distributed version control system, inspired the notion of pull and push. However, prior to popularity of Git, the terms revious and merge were more prominent. Nevertheless, let us understand frequent pulls promote CI. Working on your local branch for an extended period without often pulling changes is handy, but it is also quite likely to result in a flurry of merging issues. This occurs when, in big development teams, hundreds of code changes are submitted to the remote repository every day, considerably altering it and raising the likelihood of encountering merge conflicts from a developer who seldom clicks the pull button. On the other hand, such situations are rare in teams that frequently pull and push code changes. This is one of the most important principles of CI as it helps avoid merge hell. Validating every code change. You validate your code change for compilation issues, failing unit test, failing the integration test, and other quality checks. You first do this locally on your local workspace laptop, or and next on the build server when you push the changes to remote repository. This practice makes sure that every commit is validated to see its impact on system. Afterward, make sure to share your result with the team. The idea is to get the instant feedback on the changes that you have been made. Fail fast. We think that the following idea is based on Murphy's law, which states that anything that can go wrong will go wrong. Building on that, in context of software development life cycle, we may argue that if failure is unavoidable, it is preferable to fail sooner in production rather than later. Pulling code often changes often, and verifying each code change enhances the likelihood of identifying merge problems in functionality and quality concerns, hence failing quicker. Let us understand the idea of fail fast a bit differently. Concept of fail fast advocates that all the pipeline stages such as validating, merge issues checking for compilation issues, unit testing, integration testing, static code analysis, and so on must be performed sequentially for a particular code change rather than simultaneously. This is because building the code is pointless if there are merge issues. Similarly, running unit testing is pointless if the build fails, and so on and so forth. In other words, stop as soon as you find there is an issue and try something else. Automation acts as a catalyst. From finding failures to successfully publishing your application, automation accelerates everything. Automate anything you can, whether it is code compilation, unit testing, integration testing, static code analysis, packaging the finished app or service, and so on. Testing is the most time consuming and repetitive operation among the others. Thus, automating the testing process may considerably boost the speed of software delivery. The testing process, on the other hand, is more difficult to automate than the build, release, and packaging phase. It usually takes a lot of effort to automate nearly all the test cases used in a project. It is an activity that matures over time. Hence, when beginning to automate the testing, we need to take a few factors into consideration. Test cases that are of great value and easy to automate must be considered first. Automate the testing. For example, automate the testing where the steps are same but they run every time with different data. Also automate the testing where a software functionality is tested on various platforms. Additionally, automate the testing that involves the software application running with different configurations. Later in sections, we will discuss the significance of a CI tool in automating and orchestrating the CI process. Continuous feedback. The software development process is analogous to a factory assembly line. The delivery of new feature and upgrades flows from left to right. Far left of the pipeline is where development takes place, and far right where your application is operating in the production. As depicted in the following diagram, consider such an assembly line with single feedback loop flowing from operations team to development team. This is operations team and this is development team. This is this is development team and this is operations team in the production. Okay, feedback loops. Because there is a single flow moving backward in such case, developers will know whether their modifications were produced well function until the application is launched. Another thing to keep in mind is that the time it takes for the feedback to reach developers equal the time it takes to bring a feature from development to deployment. One such method with limited feedback loops is the waterfall model of the software development. In this model, the first feedback occurs when all code is integrated, the second when code is tested, and the final when it is put into production. Nothing tangible can be done quickly when operation team complain about a failure in production whose code was created a year earlier. We require more immediate feedback, and that is the aim of continuous feedback, to have more and more feedback loops in our software development lifecycle that are close together and happen faster. One such example is the practice of peer review, which often occurs throughout the development process. During peer review, the proposed modifications are assessed by a senior developer to assert whether the changes will function as intended, as shown in the following figure. बे भाई यार वही तो दिक्कत है इसकी। अब सही है थोड़ा, इतना ही होना चाहिए यार। हम्म How to practice continuous integration. To understand how CI is practiced, we must first realize that it is constantly evolving ecosystem of tools and technologies. In this section, we'll go through most of them. At the end of this part, it will be obvious how these separate components and their associated tools contribute to the realization of the core concept of CI outlined previously. Besides, the subsequent chapters of the book are detailed through elaboration on the process presented here. As a result, the current section is crucial. The topics discussed in the following sections are structured sequentially and in accordance to the various stages of an automated CI pipeline. So let's start with the first and foremost aspect of CI, version control system. I read all of this before. All of this. Not this, but I read ProGit book just an hour earlier. I have not completed all the chapters, but enough that I understand version controlling. A version control system helps the team in controlling changes to the project source code. It does this by monitoring every code change made to the source code, resulting in the detailed history of who modified what at any given time. It changes developers. It enables developers to work in their own workspace. Hmm. Everything that is necessary for delivering the software application should ideally be version controlled and tracked, including the software dependencies that are tracked in slightly different way using a binary repository manager, a DevOps tool for managing all the artifacts. Nexus is used. Sonatype. अरे यार मैंने सीखे तो थे यार. मैं भूल रहा हूँ यार, काफ़ी चीज़ें मैं भूल रहा हूँ. पार्ट 2 पार्ट 1 था. वीडियोस. सोनार क्यूब था एक, नेक्सस था, टॉमकैट था. सोनार क्यूब, नेक्सस, टॉमकैट आता है मेरे को. ठीक है, तो ये बात कर रहे हैं नेक्सस की. नेक्सस इज अ आर्टिफैक्ट रेपो मैनेजर used to manage all the build artifacts, container images throughout the software development lifecycle of your application. We shall see later in this chapter. You can even expand on this idea by versioning code to manage and synchronize infrastructure configuration and application deployments. This is known as GitOps. A version control tool offers features such as tags to mark important milestones in the software development lifecycle, and branches to enable independent development that will ultimately be merged back to where it came from. ठीक है, ठीक है, ठीक है. Parallel development. Branching allows parallel development. It allows developers in a team to work on individual versions of code at the same time. To understand this, consider a software development project that has all its source code stored in a Git repository with a single main master branch. Assume there is requirement to deliver 2 new features and 2 different developers from a team are picked to work on them independently without interfering with each other's work. The solution is that they would use branches. Every developer would create their own branch and work on it in solitude. When they have completed their work and the CI pipeline running on their separate branches is green, the changes are merged back to the main branch. Though there are no restrictions on how branches can be utilized, it is recommended that certain industry standard branching methods be employed. Git flow workflow and more recently the trunk based workflow are two such branching strategy. Git flow is more restrictive development paradigm in which not everyone has the privilege to make modifications to the main source. This keeps bugs to a minimum and code quality to the highest level. On the other hand, because all the developers have access to the primary code, trunk based development is more. अच्छा, Trunk-based is more vulnerable branching strategy. Nevertheless, it allows team to iterate fast. Git flow workflow. Git flow is a branching methodology that utilizes multiple branches to organize the source code. In the workflow, uh, shown in the following diagram, the main master branch is kept clean and only contains releasable ready to ship code. All development takes place on feature branches, with development branch acting as central location for integrating all the features. मर्ज मतलब एक ही बंदा करेगा इसमें. फीचर ब्रांच, डेवलपमेंट ब्रांच. ओके कूल. ये मेन ब्रांच है, ठीक है. ये फीचर निकले हैं, एक फीचर से बहुत सारे फीचर निकल गए हैं, ठीक है. Takes place on feature branches, the development branch acting as central location for integrating all the features. You see, we have released the branches that were taken out from the development branch where there is stable branch. All bug fixes for release are performed on the release branch. There is also a hotfix branch that is created from main and master branch when the hotfix is required. Trunk-based workflow. Trunk-based branching allows and encourages use of main master branch as a single location to track all significant milestones for software development lifecycle. You may still create tiny temporary feature branches from main, but you must merge them into as soon as possible. Someone who has been IT for more than a decade will find it as amusing to see the trunk base is popular again. When version control and CI were new concept was what most teams use. Then Git flow workflow became popular for good reasons and only to be overthrown by trunk-based workflow again. Trunk-based branching model. Just one CI/CD pipeline tracks the main master branch is required. When commit occurs, the CI/CD pipeline is activated, which results in releasable candidate. Any commit to main master branch might be a potential release candidate, a hotfix, a new feature, because everyone is permitted to merge and change to the main and master branch. Strict code review procedure is required. This methodology is better suited for high performance contemporary software projects where the entire CI/CD process is automated from start to finish. Microservice based software development projects in particular can benefit greatly from trunk based Kubernetes. So we are going to use trunk based workflow again. First, monolithic process based. I think I should create a new repository. देखो यार, Git ज़्यादा आता नहीं है भाई साहब. पहले हम जाएंगे github.com पे. Shall I just make changes to? So shall I open it? Open DevOps notes. CD documents ls cd DevOps notes ls cd Jenkins ls cat 01 txt. I remember. What I remember is that git log add comprehensive. अच्छा. 01 txt or notes.txt. Jenkins book notes. I really like this line. This shall be useful for me. So for microservice particular benefit from trying those since they have faster CI/CD process. What is the date? 12 January 2026. I started reading learning continuous integration with Jenkins. These are some lines which I enjoyed. These are some lines which I may require in future. Cool. This branching model lacks feature branches. 1 second, where I was. Lacks feature flags can be used instead. Feature flags, also known as feature toggles, are the software development approach that allows you to publish software programs that have dormant features that may be toggled on and off during runtime. Verify every code commit for build errors. First and foremost step of any CI pipeline is to check whether the code changes are compilable. Basically, we try to see whether we can generate working binary that can be tested and deployed. If the code base happens to be in an interpreted language, then we can check whether all dependencies are present and packed together. There is no point of moving any further in CI process if the code changes fail to compile. The process advocates that you can compile every code change and trigger a notification or feedback loop and fail the whole pipeline run in event of failure. As such, the duration of build run build time plays a critical factor in determining the effectiveness of the CI process. If the build time is long, say several hours, it becomes impractical to build every code change on an infrastructure limited by cost and availability. Automation and CI have no value if pipelines take hours to complete. Modularizing your application is an effective way to counter software builds that take longer time to build. Performing unit testing. Remember that the principle of continuous feedback to have more and more feedback loops in our software development lifecycle that are closer. Unit testing is one such feedback loop. It is closer and faster to the development stage. Without unit testing, the next level of testing is long running integration testing stage, followed by QA stage from the continuous delivery and deployment pipeline. It will normally take some time for your build to reach the QA engineering team, who will usually raise a defect if they identify an issue. In summary, if unit testing is used, a lengthy feedback cycle can be avoided. Unit test enables you to test the smallest testable portion of the programs faster. If your source code is well written, unit tests are easy to write and easy to resolve when they fail. Code coverage. Code coverage is an important CI metric. Oh, so for code coverage we use SonarQube. Hmm. Having high code coverage score is essential since detecting and resolving defects in QA. Uh, can you it was excellent for right now. Can you use can you use sonar type no sonar cube for C++ code quality analysis? More, can we chat with it? Okay, so essentially we can use it, which means we can use it C++ के लिए भी यूज़ कर सकते हैं अगर करना है तो. Having a high code coverage score is essential since detecting and resolving defects in QA is or production is both time consuming and expensive. Means you have to pay QA automation or QA engineer. QA is quality analysis. I think any piece of code that lacks a matching unit test is possible risk. Uh, any piece of code that lacks a matching unit test is possible risk. Therefore, having a greater code coverage score is essential. It is also worthy that the code coverage percentage does not ensure the functionality of the code covered in unit test. Percentage of code coverage is calculated during unit testing. Almost every programming language has a coverage tool. However, the findings are mostly uploaded to static code analysis such as SonarQube. Now they're talking about SonarQube. I know SonarQube. I have used it. I can install SonarQube. I can develop the whole pipeline. But for that, I'll have to learn Jenkins completely. Percentage of code coverage is calculated down where they are shown on a lovely dashboard among other data concerning code quality. Static code analysis. Static code analysis, sometimes known as white box testing, is a type of software testing that searches for structural features in code. It determines how resilient and maintainable the code is. Static code analysis is conducted without actually running program. It differs from functional testing, which explores the functional feature of the software. Static code analysis is the evaluation of software's inner structures. It doesn't question code's functionality. Static Code analysis tools such as Sonar Cubes comes with a dashboard to show various metrics and statistics for each CI pipeline run. Static code analysis is triggered every time a build runs after unit testing. SonarCube supports many languages such as Java, C, C++, Objective-C, C Sharp. Objective-C I think is used for iOS app development. C Sharp is used for .NET and implementing backend engineering on Microsoft .NET stack. PHP again for backend engineering. I don't know, Flexi, Groovy is a scripting language, JavaScript is a web, you know it. Python, you know it. PostgreSQL and SQL, COBOL, I don't know COBOL. Why is it used even today? When you run static code analysis on your source code, the Sonar Cube tool generates a report containing important metrics concerning the quality of your code. These metrics are grouped into explicit sections: complexity, duplication issues, maintainability, readability, reliability, security, size, and test. Every static code analysis report is published to its own project specific dashboard on SonarCube, branch by branch. However, the measurements are shown collectively for the project as a score or a number or by using a time series graph. Talking about metrics, let's look at one such section: test. This covers a variety of metrics relating to code coverage and unit testing, such as the following: uncovered lines, the number of source code lines that were not covered by the unit test, the number of unit test duration, the collection of duration of number of failed unit tests, and the list goes on. Security is another key quality metric section. It includes the metrics such as vulnerabilities, the total number of security problems discovered. Remember the Apache log4j security flaws? I don't know about it. This is where you detect it and stop it from. How about we go and search about this Apache 4 security flaw, Wikipedia. No definition found. No problem, no problem. Those are 21 में 2021 it happened. Particularly the log4 shell will not allow attackers to execute arbitrary code on affected systems by exploiting improper input validation in the logging framework. This vulnerability is critical due to its widespread use in Java application and the ease with which it can be exploited, receiving the maximum severity score. Oh damn. किसी ने सोनार क्यूब यूज़ नहीं किया होगा अपने प्रोजेक्ट में, इसलिए उनका vulnerability आ गई. That is sad. Quality profiles and rules. Quality profiles are collections of rules that you choose to apply during static code analysis. This can be done from SonarCube dashboards. Quality profiles are language specific, hence you would usually see more than one quality profile assigned to the project in SonarCube. The issue you see for a particular static code analysis run are generated based on SonarCube rules they broke. SonarCube rules are categorized as follows: code smell, maintainability, bug, reliability, vulnerability, security hotspot, security. Quality profiles can have rules added or removed. However, this is normally done by a specific governance team from the organization's cybersecurity department, which oversees the evaluation of new and odd rules on a regular basis and builds custom quality profiles to be utilized by development teams. Quality gates. So far, we have looked into quality metrics and profiles and rules, but how can we turn this insight into action? The answer is quality gates. A quality gate serves as a checkpoint through which a pipeline flow must pass. Quality gates are in practice combination of specific conditions An example of quality gate condition can go as follows: the number of bugs in less than 10, percentage of code coverage is greater than 95. CI/CD pipelines can be configured to pass or fail based on the result of the quality gate. In subsequent chapters of the book, you will learn how to achieve this in practice. Quality gates are normally decided and applied by development teams. The following diagram depicts the various stages of CI/CD pipeline, emphasizing the crucial function of quality gate as a pivotal point where the code must match set of quality standards before it can proceed to deployment. क्वालिटी गेट अगर फेल होगा तो डेवलप दोबारा करेंगे, बिल्ड दोबारा करेंगे, यूनिट टेस्टिंग दोबारा करेंगे, सोनार क्यूब से दोबारा गुजारेंगे। अगर पास हो गया तो पब्लिश होगा, क्यूए के पास जाएगा, फिर डिप्लॉय होगा, ऑपरेट करेंगे, फिर CI/CD कूल अंडरस्टूड। If code fails to meet these standards at the quality gate, it is returned for additional development and improvement, guaranteeing that only high quality thoroughly tested software advances to the continuous deployment phase of the release and operation. अच्छा, मतलब Kubernetes और Docker पे डालने से पहले क्वालिटी गेट से पहले जाएगा, अगर फेल होता है तो दोबारा डेवलप और बिल्ड होगा, then again it will go through testing, SCA. If it passes, publishes, QA, deploy. Cool. Employing a binary repository manager. CI pipelines generate binary artifacts that are deployable apps and services. When you choose to run the pipeline for every commit made to the trunk branch, this happens much more quickly. As a result, these build packages must be saved and managed somewhere for subsequent usage. And this is usually done using a binary repository manager. But what exactly is binary repository manager? Binary repository managers such as JFrog Artifactory. Instead, I was using Nexus. I have never used JFrog Artifactory, but I have to learn it. Also, system for storing, managing, and promoting build artifacts by incorporating metadata. Metadata attached to every artifact is a group of properties. In addition to storing build packages, a binary repository manager is also responsible for keeping track of dependencies that go on into building your project. Let us see some features of the binary repository manager. Accountability builds. A binary repository manager such as JFrog Artifactory is essential for not just storing the build artifacts but also accounting for them. For example, every artifact hosted on Artifactory server has a unique URL. Cool. On Nexus also we have a unique URL. This enables you to embed a specially built artifact into configuration scripts such as chef recipes. For example, we are scripting on Python or we are scripting on Bash. Scripting we can embed it, cool, and utilize them afterward to distribute packages on multiple machines. Ansible configuration management. A property singular or a property set plural is another essential feature including with Artifactory. It makes it possible to query artifacts using GUI, short for graphical user interface, or API, application programming interface. Opening the path for attached to the artifacts as XML or metadata. Wait. A property is an entity with a key and a key value pair. Key value pair is also in Python and is also part of AWS. Set is artifacts as XML or metadata. This makes it possible to query artifacts using GUI. APIs, short for opening the path to automation. Similarly, properties may be assigned, unassigned, or modified using GUI and API instructions. Artifact housekeeping is one of many use cases of the property feature. For example, in trunk-based CI system, every commit potentially results in build artifact. This causes many build artifacts to accumulate on the Artifactory server in a very short amount of time. However, not all these artifacts will be published. Some may fail QA testing, while others will simply be ignored for a new version. This calls for an automation script to identify and clean artifacts that are older than a particular period. Now comes the part of bash scripting. Since date of creation is default auto-signed property of artifact. Wait, I had a doubt. Discord. When we persist, no, let it be, sorry. Since date of creation is default assigned property 2 of an artifact, you can use AQL, short for Artifactory Query Language, another feature of Artifactory, to query artifacts using date of creation property and delete them. Build promotion. A binary repository manager such as JFrog Artifactory or Sonatype Nexus helps you in architecting a fully automated CI/CD pipeline workflow through another built-in feature called build promotion. To understand how it works, imagine a fully automated continuous deployment pipeline with stages such as downloading the build package from Artifactory, deploying the package in QA environment, running the automated test, and lastly deploying the solution in production on Kubernetes or Docker or on premises server. This build promotion feature in Artifactory takes care of promoting the status of the Artifactory by updating the build info data. Build promotion is configured to trigger from various stages of CD pipeline using APIs. Cool. Build info data is metadata published along with the artifact by continuous integration pipeline to Artifactory. It includes the commit ID, CI pipeline URL, build number, and a lot more information. Software dependency manager. I have not used. Oh, I have used Maven. I have used Maven and I have used Gradle previously. So, but they are dependency managers for Java based applications. So for example, you are using Spring Boot to develop a web application, Java Spring Boot library to develop an application. So Maven or Gradle can be used. Maven is a bit older, but it is still used and still relevant, while Gradle is used for Java, TypeScript, Java and Kotlin. Using these open source frameworks, however, present two major challenges: administration and security. The Artifactory tool helps you to manage dependencies as well as check them for vulnerabilities. It serves as one-stop shop for accessing all the different dependent packages needed to build your projects. This is often done by creating as many remote repositories as needed within Artifactory, each of which is linked so its appropriate package source on the internet. With an internal Artifactory URL, a remote package repository in Artifactory allows you to list all the accessible packages from the internet. All you must do is reference these libraries using correct Artifactory URL when writing your code. Since these Artifactory URL get tracked by their version control toolkit, You can easily generate a bill of materials BOM used to build particular version of your software application. Okay, so they are talking about pom.xml file where we list down all our required dependencies, and I think there is a code snippet or mm, ex- pom.xml snippet on Maven site or Gradle site which helps us to do that uh, thing very fast. Remote repository is only reference to the actual source. Nothing else is ever downloaded to Artifactory server but the metadata. Software composition analysis. Another advantage of utilizing a binary repository such as Artifactory is built-in security tool that scans open source package libraries for vulnerabilities, checks open source libraries for license violations. Tools such as JFrog X-ray, part of JFrog suite, scan your package libraries for OSS open source software components and security vulnerabilities and create a report before they enter your source code. So software composition analysis can also be incorporated as separate stage in your CI pipeline using others SCA tools such as Black Duck. Orchestrating using a CI/CD tool. At heart of CI system sits a CI/CD tool. Its responsibility, it, its role is seamlessly orchestrate other DevOps tools to achieve a fully automated CI/CD workflow. Thus, a good CI/CD tool must provide, at the very least, the following features: seamless integration with various software tools and technologies, powerful pipeline syntax to create robust automation, intuitive pipeline visualization and notification capabilities. भाई बहुत बड़ी बुक है, ख़त्म कब होगी यार ये वाला चैप्टर, कब ख़त्म होगा? क्वेश्चंस पे रुक जाऊंगा मैं, उसके बाद मैं चाय पीऊँगा। ऑटोमेशन वाली कर ली क्या? पाइपलाइन नोटिफिकेशन यहाँ पे हम various stages of CI pipeline are scripted using their corresponding tools and technologies. For example, to build code written in Java, you require Maven libraries and Maven build tool. Likewise, to build a code written in C++ or C Sharp, you require Nugget packages like Microsoft build tool, and so forth, and so on and so forth. Similarly, to deploy the built application on given infrastructure, configuration management tools such as Ansible. I know Ansible little bit, but heck, I'll have to learn it again. I went soft. The list goes on if we continue to include all other stages of software development life cycle. Because there is a wide variety of tools and technologies, a good CI/CD tool is expected to integrate well with as many of them as it can. Jenkins is one such versatile tool that has stood the test of the time. Its ecosystem of plugins allows it to integrate with almost all the tools listed on the DevSecOps periodic table. Jenkins सबके साथ चल सकता है. Jenkins चल सकता है Software Configuration Management, which is Maven, Binary Repository Manager, which is for me Nexus, Testing Automation Tools, ये नहीं पता मेरे को, Cloud AWS, on-prem cloud, which is also in premises server, and AWS. Software composition analysis tools, don't know. Version control system is Git. Instant messaging tool is Apache Kafka or Redis MQ. Static code analysis tool for me will be SonarQube. Planning tools, Jira, or for container services it is Docker. For monitoring tools it is Prometheus and Grafana. For build tools, already told, Maven or Gradle. Automation through pipelines. Earlier, automation pipelines were first built manually on CI/CD server using UI-based parameters. But as development teams grew and automation pipelines proliferated, engineers found it increasingly challenging to maintain them because the only method to back up and version the pipeline was to create a backup of whole CI/CD tools. Jenkins, Freestyle Job, and TeamCity's build are two examples. But thanks to the pipeline as code movement, automation pipelines can now be defined as code, making it possible to version control them alongside source code. Oh, so for whole software development cycle, your code is going to be version controlled and your CI implementation code, CI pipeline implementation code will also be version controlled. And not just CI/CD pipeline, describing your complete infrastructure as code is also a reality. Pipeline as code allows you to share, examine, and create longer automation pipelines. Furthermore, to reduce redundant pipeline code, it is even possible to compose reusable pipeline components as libraries using shared libraries feature in Jenkins. Pipeline code, particularly Jenkins pipeline code, is DSL, short for domain specific language, built on top of Groovy programming language. Pipeline code syntax could be scripted or declarative and always follows a structure. Pipelines as scripted syntax are much more flexible and extensible than their declarative counterparts, but the latter is more straightforward to write. However, for CI/CD purposes, it is always recommended to use declarative pipeline syntax. We'll learn more about pipelines in upcoming chapters. Pipeline visualization and notification. If your pipeline run fails for some reason, then you might want to know at what stage or what step it failed. When you find where it failed, you would then want to know why it failed, and that's what exactly the pipeline visualization feature in CI/CD tool is meant for. A good pipeline visualization system helps you to pinpoint the actual failed stage or step of a pipeline in intuitive manner. It also segregates pipeline logs by stages and steps, so you don't have to scroll through entire pipeline log. A good notification system, on the other hand, allows you to get quick feedback about status of your pipeline run. This is done by adding notification triggers inside your pipeline code as a post step after every stage. Therefore, if the pipeline starts to fail, you immediately get either an email, a message on chat app, even a ticket on Jira dashboard. Parallelizing through distributed builds. We already know that pipeline is separated into stages: build, unit testing, SCA, followed by publishing to binary repositories. Hmm. Hmm. Amazon Machine Image, EC2 plugin, IAM, EC2 auto scaling, EC2 instances, and Jenkins agents. Every commit to your source code repository activates a pipeline on Jenkins. As a result, at any given time, there are several stages of various pipeline runs vying for a machine to operate on. As you can expect, a farm of machines is required to complete all the stages. In Jenkins, pipeline stages are executed on cluster of builds agents called build farm that is connected to the Jenkins server rather than on Jenkins server itself. The build farm might be a cloud provider, on-premises VMware equipment, a Docker host, or a Kubernetes cluster. This is called Jenkins distributed build architecture. It is covered in detail in the present book. Control plus. The preceding diagram is example of Jenkins build farm built using AWS EC2 instances that auto-scale on demand. Similarly, following the example of Jenkins build farm built using Kubernetes cluster. This brings us to end of this part. We have discussed the practice of using a version control system, building every code commit, emphasizing using unit testing, static code analysis to check quality of code, using binary repository managers to track builds, executing build across many computers in parallel, utilizing a CI/CD tool to save time and effort. Everything covered in this section constitutes the various CI pipeline that fulfills the key principle of CI. Now let's look why we should utilize. Answer is straightforward. CI practices are critical because they enable teams to fulfill modern software demands. But what are these demands? What benefits CI help fulfill these demands? And how they do so? This is what we'll cover in this section. Faster time to market, also known as the lead time or time to delivery. TTM is the time it takes a feature to get from its origin, typically a code change to deployment in production. A higher TTM number indicates that features are being developed, tested, and delivered more slowly and infrequently. Most current software programs and services need more frequent software upgrades. So let's see some advantages of CI/CD that help achieve a lower TTM value, time to market. Freedom from long integration, avoiding tolls. CI advocates for regular iterations of your work with the main code. This method, as we previously observed, helps engineer to avoid merging issues that might otherwise take weeks to fix. With a simple practice, we save weeks of time. Rapid feature development velocity. CI from a technological standpoint helps team to operate more efficiently. Teams following a CI practice employ an automated and continuous approach for developing and testing and integrating code changes, resulting in speedier development. This allows developers to spend more time focusing on their code while CI automation does the rest. Furthermore, the mindset of failing fast and attempting different approaches to develop a feature, along with constant feedback loops from throughout the CI/CD pipeline, enables developers to be agile, developing more features, volume, and variety. In using a trunk-based development model, every commit is peer-reviewed, built, tested, analyzed, and deployed, assuming it passes all the stages of CI and deployment pipeline. Also, having a distributed build architecture in place allows pipelines to run in parallel. As a result, every commit is a potential feature release candidate. Furthermore, employing a globally available distributed version control system in conjunction with the globally accessible CI server allows geographically distant teams to collaborate on a bigger project and deliver more features. The change failure rate metric is a nice way to describe the quality of your code. It refers to the percentage of the features deployed in production that causes the downtime or a bug resulting in a rollback or a hotfix. A lower CFR points toward a robust and effective CI process. In other words, the pipeline is effective in detecting quality issues as early as possible. So let's see some advantages of CI/CD that helps us achieve lower percentage of CFR. Change failure rate metric. Rigorous code review process enables developers to identify possible code quality concerns before changes are merged into code. Code review, often known as peer review, is the process of having your code changes. Posture is very important. Code reviewed by a more senior developer before merging them into the main branch. Furthermore, by performing static code analysis on the developer's local branch, code changes may be validated against quality criteria such as readability, maintainability, complexity, duplication size, reliability before code changes are integrated into main branch. Of course, SCA occurs one or more during CI pipeline run on the main branch. These CI practices allow code quality to be built in, early defect detection. As we saw previously in the chapter, automated testing and unit allows you to test smallest testable components of the software as quickly as possible. It enables the detection of error as early as feasible before they are identified in the QA environment, staging, and production. Unit test cases are simple to develop and pay higher dividend. Thus, by considering quality in capability of code, spotting quality concerns as near to development as feasible, using affordable automated unit testing software development tools may obtain a lower CFR change failure rate percentage. Highly secure applications. If you cannot measure it, you cannot improve it. Lord Kelvin, software application security is something very similar. It is an imperceptible and tough to measure entity. Security risk can only be anticipated and speculated until a breach occurs, and all existing security measures are built against such anticipations and inferences. Therefore, CI practices or any other practices for that matter cannot guarantee that an application is completely secure. But they do help you to prepare well. Continuous security. The culture of thinking about security about throughout the software development lifecycle as a collaborative effort as opposed to something that is done by security team in the end is continuous security, also popularly known as DevSecOps, short for development security and operations. The term continuous security is much better as it sounds more actionable. Continuous security methodology encourages adding security tests not only when developing the application but also while performing QA checks on the source code during the CI phase. It is reasonable for us to suggest that if we extend this concept, we also need to subject the infrastructure and pipeline code to security checks. Security analysis. Scanning third-party dependencies, whatever you choose to call them, software dependencies, software libraries, or third-party binary packages, developers frequently use them to speed up the development processes of their applications. These third-party libraries are one such point of entry for malicious program to enter your system. However, CI practice of using binary repository managers such as Artifactory enables you to avoid downloading questionable third-party packages by identifying and tagging them directly in the package repository through using additional tools. Static code analysis while scanning third-party packages is excellent thing to know. What about identifying security flaws that are carelessly introduced during the development process by the developers themselves? This includes things such as stored password, API authentication tokens, and so on. This is precisely what CI practice of checking code for quality accomplishes. It searches for security related vulnerabilities in addition to other security tests. Software composition analysis. कर लिया यार ये तो cost effective system. Technology will only continue to become more integral to business in future, especially as a consumer demands rapidly shift to digital models. IT can serve as a direct line from innovation to great profitability and market share in this transition. Company spending tends to rise as software becomes more and more essential at their core operation. Ultimately, they start considering the cost factor associated with software development. Almost every facet of CI/CD methodology helps to reduce the cost of software development without sacrificing quality, security, and speed. Automation using pipelines. Automation using pipelines, notably pipeline as code and infrastructure as code, enable development teams to spend less time maintaining the CI/CD platform and its underlying infrastructure and more time building features. The developers need to ensure that the pipeline and infrastructure code are error free. This significantly reduces the maintenance overhead, saving money and, more crucially, time. Pinpointing failures with ease. CI practice advocates using CI/CD tool to orchestrate CI pipelines. As previously, a good CI has informative dashboards and intuitive pipeline visualization system that assists the developer in determining the exact failed stage and step of a pipeline. It also divides pipeline logs into stages and phases, saving the developer from having to read through full pipeline log. This allows faster debugging of issues, essentially saving time and cost. Configuration as code can refer to either of your application machines. Configuration being written as code. Configuration as code is the practice of defining the entire configuration of application or a machine as code through a configuration file, usually a JSON or YAML file. For example, let's consider Jenkins as our application. We can express the Jenkins server complete configuration as code by utilizing a feature in Jenkins called this functional enable engineers to swiftly start up a backup Jenkins server in the event of original server fails due to a problem. This allows pipeline to restart without additional delay and saving time and resources, ultimately saving money. ठीक है. Machine configuration as code is popularly known as software configuration management. Some of the most prominent software configuration Ansible, Chef, Puppet. Ansible is used for. They enable configuration across hundreds of computers using a single recipe file and also used to deploy applications in production through container technologies have more eclipsed them. They remain relevant to the project that run programs in Windows and Linux compute server. This managed operational overhead by paying the way of automation of development and rollback process on hundreds of production computers, saving time, resources, and ultimately saving money. This brings us to the end of the section. We have learned CI approach can help teams achieve faster time to market and high software quality to build highly secure software application in cost effective manner. We begin this chapter by studying basics of CI. ठीक है. अगर यार समरी क्या करूँ पढ़ के. I will attempt this. So we are live. एक बार देख लेता हूँ ना चल रहा है नहीं चल रहा. I have to take a break. I have to take a break. I'm going and pouring my water, making my water hot. I'm drinking water. August. वो तो है नहीं भाई. फोर्थ का डी होना चाहिए. फोर्थ का डी. कॉम्प्लीमेंट। इसका बी है, फिफ्थ का बी है। कूल भाई कूल। इंजीनियरिंग, रुक जाओ। चैप्टर 1 कंप्लीट कर लिया है, इसमें चैप्टर 2 है। खाली मेरे को चैप्टर 2 तक करना है। पार्ट 3 यहाँ से स्टार्ट होगा। ये 4 चैप्टर मैं कल तक नहीं कर पाऊँगा, आज मैं खाली यही करूँगा। खाली इतनी changing landscape starts with complex Jenkins server architecture designed to balance the demands of operational efficiency and cost effectiveness and security. We will use the infrastructure as code and Jenkins configuration as to build a strong and flexible platform as we secure our manufacturing assembly line with the precision of locksmith. We will integrate the sophisticated user authentication systems and dwell into the nuances of permissions and credentials. Our goal is simple: to turn Jenkins into a fortress, protecting the critical data that passes through the veins of our CI operations. We will turn the extra DevOps technologies. भाई आवाज़ आ रही है क्या? आवाज़ तो भी है। Studio.com content life We are live. We are live. Finally, we ascend into clouds, embracing the virtual machines and containers' limitless possibilities. This is where our CI infrastructure takes flight, delivering the level of scalability that responds to the flow of demand with agility. We will provide our CI systems with flexibility to expand the contract in tune with pulse of development needs and by orchestrating the dance of cloud services and container orchestration. So we are here with our first chapter. Well, first describe importance of CI to among other things. This chapter describes how to plan, deploy and maintain one. Our goal is to design and deploy a resilient, cost-effective, secure, high-performing and operational Jenkins setup. We will accomplish this setup by looking at Jenkins server architecture followed by evaluating few Jenkins server deployment scenarios against the well-architected framework. Following that, we will cover the two most popular ways of deploying Jenkins and learn how to implement them step by step. While doing so, we will incorporate some key DevOps practices such as infrastructure as code and Jenkins specific approach called Jenkins configuration as code. Finally, we'll also go through the Jenkins server maintenance. CI ecosystem is larger as it contains not just this but also other DevOps tools. Other aspect of CI ecosystem will be presented gradually through the next few chapters of this book. After completing this chapter, you should be able to do the following: understand Jenkins server architecture and system requirements, plan a Jenkins setup by evaluating deployment scenarios and infrastructure choices, gain proficiency in Jenkins configuration as code, to author and apply initial server settings for Jenkins, deploy your Jenkins setup on managed Kubernetes cluster, deploy your Jenkins setup on cloud instance, acquire knowledge on key considerations for upgrading and backing up a Jenkins server to ensure a smooth, reliable process. यार मेरे को एक डाउट है कि पहले जेनकिन सीखना चाहिए डॉकर सीखना चाहिए. ओह रिस्ट्रिक्टेड एक्सेस भी अभी अभी मैं रूल तोड़ देता. व्हाट टू लर्न फर्स्ट, जेनकिन्स और डॉकर. क्यूबरनेटिस तो डॉकर के बाद ही आएगा ना. Recommended to learn Docker first as a containerization and creating यार मैंने डॉकर थोड़ा थोड़ा सीख रखा है पहले, लेकिन कोई नहीं. Docker, then Kubernetes, then Jenkins. यार चैट जीपीटी और एआई भी तो वही हो गया ना, है ना. Jenkins disable. Not now. Jenkins or Kubernetes. Move on to Jenkins, then Kubernetes for orchestration of containerized applications. कोई नहीं, अभी मतलब डॉकर के मेरे को फंडामेंटल्स थोड़े बहुत पता हैं. आई नो डॉकर्स फंडामेंटल, बट I do not know Docker in depth. So just after Jenkins, I'll be reading Docker's book. This chapter is divided into three parts: planning, deploying, and maintenance. Except for the deploying part, other two parts do not have any technical requirements. For detailed technical requirements for the deploying part, refer to the following subsections located under the step guides for deploying your Jenkins setup. Preparatory steps, local deployment environment prerequisite. These sections offer detailed information and instructions regarding the necessary technical prerequisite. Furthermore, you can access the code referenced in this chapter by visiting ये वाला तो है मेरे पास, है ना? F12 क्यों दबाया मैंने? F10 बैकस्पेस दबाया था. QW. CD. So we are using this chapter, CD chapter 2 ls. अच्छा, Jenkins के लिए upgrade Jenkins variables dot override dot jvm dot options dot txt cat Jenkins installation dot sh. नहीं यार, ये मतलब पुराने जेंकिंस की है. तो अगर जहाँ पे चैप्टर, when this chapter will say that you have to install Jenkins, then I will be using tab खोल लेते हैं, open new tab, cd, then I have labctl. It's crucial to ensure optimal resource allocation, scalability, security, customization, and cost optimization. It sets the foundation for a stable and efficient CI/CD system that aligns with your organization's specific need, accommodates the future growth. You will discover a comprehensive guide on effectively planning your Jenkins setup. So let's begin. The Jenkins server architecture. Jenkins design is based on distributed approach, with the master node coordinating the build process, delegating real world to agent nodes. Let's go through the components of server design depicted in the preceding figure. Acha. This is master node, and where is agent node? So what master node is doing is, master nodes coordinating the build real work. So master node is just delegating work. Nodes, plugins, pipeline, credential, global configuration, dynamic, Kubernetes, Docker, static is Linux, Windows, virtual machines, on premises. Then this is cloud, so this is taking data from here. Pipelines are here, Jenkins Update Center, DevOps tools, RESTful API. Centered on the master node, also known as the Jenkins controller or the Jenkins server itself. It runs the whole system, oversees key activities such as scheduling, distributing pipeline jobs, monitoring agents, providing a web interface for user interaction. The master node is responsible for coordinating the CI pipeline process. Agent nodes, also known as worker nodes, are in charge of carrying out pipeline builds allocated to them by the master node. So master node just allocates carrying out pipeline builds. They might be container or virtual machines. So this is virtual machines. with different operating systems and configuration. Additionally, agent modes can be dynamic, created during the pipeline and destroyed afterwards. A static, pre-created, persistent Jenkins plugin allows us to connect the agent nodes to the master node, and multiple agent nodes can be linked to a single master nodes, allowing built. Jenkins has a robust ecosystem of plugins that enhance its capabilities. Installing and configuration plugins allow you to interface with wide range of DevOps tools with RESTful API backend. They offer capabilities such as source code management, notification, testing frameworks, development options, among others. Jenkins support pipelines, which are sequences of interconnected stages that make up the CI/CD process. You can create a Jenkins pipeline either using code or through the Jenkins user interface. A pipeline often consists of numerous stages of build, unit test, static code analysis, publish, and a pipeline may be viewed controlled using pipeline plugins for Jenkins such as Blue Ocean. A stage is specific operation that Jenkins pipeline performs, such as generating code, performing tests, and deploying the application. The credential features in Jenkins is used to securely store sensitive data such as password, API tokens, SSH keys, and other authentication credentials required by Jenkins pipeline and plugins. The credential feature prevents sensitive data from being exposed in plain text inside pipeline code or build logs. The Jenkins web interface is often used to manage credentials. The credentials page on the Jenkins user interface allows you to create, edit, or remove credentials. Credentials can be assigned to specific jobs or shared across numerous jobs and plugins. Jenkins global tools कहाँ है? अच्छा इसी को कहते हैं global tools. Is a feature that allows Jenkins to install and configure tools globally across Jenkins environment. These tools can include version control tools, build tools, static code analysis tools, or any other software required by the pipeline. By installing tools globally, they can be easily accessed by the pipeline stages running on any Jenkins agent node. Administrators can specify tool installation in Jenkins settings. Pipelines can reference them from using environment variables or specific steps in pipeline code. Global tools streamline the setup process and ensure consistency across build environments. Jenkins global configuration refers to the centralized settings and configuration that apply to the entire Jenkins instance. It includes various system-wide settings such as security settings, email notification configuration, global tool installation, plugin management, and other administrative preferences along the Jenkins plugin configuration. Global configuration allows administrators to define and manage these settings in one place, ensuring the consistent behavior across all jobs and agents. It provides a convenient way to configure Jenkins and global, reducing the need of repetitive configuration tasks for individual jobs and agents. Jenkins configuration as code is a way to define all this Jenkins configuration using code. We will learn about this in the upcoming. Takes this even further. It is utility for defining all the Jenkins configuration using code right before you set up your Jenkins server. We will learn more about it in upcoming sections of this chapter. In this chapter, we will explore hardware requirement, network connectivity, Java virtual machine configurations that are necessary for optimal performance of the Jenkins server. अब Jenkins सर्वर की बात हो चुकी है तो मैं खोल लेता हूँ labs.eximus.com. यार एक प्लेग्राउंड था तो यार इतना बढ़िया सा जो कॉपी किया था. माई कस्टम में कौन कौन से डेवऑप्स प्रैक्टिस है. स्टार्टअप कॉन्फ़िगरेशन 5 मशीन है इसमें. करेंगे, हम स्टार्ट भी करेंगे, करेंगे भाई करेंगे. Well, simplifying the hardware requirement is quite challenging since it depends on what shows bare minimum for running Jenkins server. Configure. Comprehending the intricacies of the Jenkins server system deployment, administrators can deploy in different scenarios. Hardware requirements of Jenkins is a quite ठीक है 2 GB रैम का सर्वर चाहिए. हमने 4 GB का रखा है. हमने 25 GB की और क्या रखी है. Sufficient if you only have a pipeline jobs and a few developers using Jenkins. However, as you use Jenkins matures, you will ultimately begin to seek some formula that provide you the right to hardware requirements. That you provide you with the right hardware requirements. That is exactly what we shall find out in this section. Let us begin with the thing. The CPU affected by a number of HTTPS requests made to Jenkins master at any given time. These HTTPS requests might come from user accessing a Jenkins server or API calls made to a Jenkins master through webhooks from the version control tool that triggers builds. The following formula can be used to compute estimated number of CPU cores necessary. For instance, if your Jenkins server is powered by a quad-core processor, roughly 100 developers are quad 4 cores with 100 build triggers, your CPU usage will be around for that very moment. Memory RAM is affected by amount of agent nodes connected to Jenkins master. The following is the formula. अच्छा, the agent अगर 100 nodes connected to Jenkins master operating system with 2 GB RAM, your memory will be around 15% of the 100 nodes stays connected. By the amount of file associated builds that you choose to keep this. If build logs are larger, it should be noted that Jenkins master stores the build logs for Jenkins pipeline. The formula can be used to compute estimate amount of additional space in megabyte. प्रीमियम है भाई साहब अपने पास, बात रखने वाली चीज़. Number of builds retained. It is important to consider that we are referring to extraordinary needs, especially when Jenkins is running in addition to initial disguise, where it encompasses the Jenkins install. Preceding host assist you in selecting the appropriate VM size. Speaking of cloud, when you consider the best category of VM for इसको मैं पोर्ट हटा दूँगा 50,000 से हटा के मैं कर दूँगा 52,255. पोर्ट स्कैन करेंगे, पोर्ट स्कैन में बहुत टाइम लगता है. reports. If somebody would like to do a port scan, उसमें बहुत टाइम लगता है, वो हो ही नहीं पाएगा, करने को करना है. Port scan कर लेंगे, उसमें बहुत टाइम लगता है. ये coding, the large number of longer-lived HTTPS connections provide INCP performance will help guarantee efficient processing. Furthermore, while the Jenkins master server does not actively run pipelines, it does not manage the whole Jenkins environment and organizes the tasks. Choosing a VM with sufficient autonomy meeting the important demands of the Jenkins master server. Easy guideline. Your resource requirement may vary depending on your usage habits and workload. Keep an eye on Jenkins master nodes. Source utilization, scale it up as needed to maintain optimal performance and reliability. Furthermore, we presume that you have established agent nodes to handle CI pipeline workloads and that nothing is specified to execute on the Jenkins master. We also presume that there are no built artifacts stored in Jenkins master. Every master node must have a return access to agent nodes. Default book numbers, however you made you. Java 8 or later version with Java 11 being common choice. JVM settings. They claim slowness even when there is no problem. Improve Jenkins as the users. Responsibly modifying variables such as heap size, garbage collection, algorithms, thread management. Specifying adequate memory limits and settings will help you prevent problems such as out of memory error or excessive garbage collection pauses, which can cause Jenkins to become unusable or crash. Locking mechanisms can be enabled to collect precise information to fine-tune JVM for best efficiency. भाई वो अंतर की बात है बहुत ज़्यादा. How big is this chapter, yaar? How big is this chapter? I think I need to take a break. Need to break. Take a break. Take a break.